let's see. So since we understood about the word count Mapreduce program, and then that the advanced like the partitioner and the combiner. So let's take us to the next level of the depth of the advanced Mapreduce, and that now we are going to learn is like how to join two kind of the data set inside Hadoop. So in case of Hadoop, you can do two kind of join, guys. One is called Mapside join, and another one is called Reduce side join. So the kind of the join how you are going to do is going to depend like what kind of the data set you have to perform the join, right? So like if you go back and based on like your experience with the data set, what kind of the data set you have worked with, right? So what you see is majority of the time, right, when it comes to the data, either you will have two huge data set that you will join together and then you will get the output, right? Or you may have like one data set that is large, huge data set, and then other data set that may be some small data set like metadata, or some kind of the fact table, or you have, and that's what you want to join and fetch the data. So in those scenario, or it where you have one small data set and one large data set and you want to join, so that's one category. Another is like two large data set and that's what you want to join. So based on the kind of the data set you have to basically opt for like what kind of the join you can go in case of the Mapreduce. So if one of your data set is small and other one is the huge data set, right? So if that's the scenario, like one you have the small table and other one is like the large table. So in that case, what you can do is you can go for the Mapside join. So what you can do is you can distribute this small table to all the machine, and then during the map page itself, you can do the join. Now, if the scenario is different, like you have the two data set, that's basically the large data set. So in that case, you cannot go for the Mapside join. So in that case, you have to go for the something called the Reduce side join if both the data set is large. So based on your data set, you will determine how you want to do that. Now the question is, if I have a small data set and one big data set, can't I do Reduce side join? Yes, you can do that. But generally, when it comes to the join, you always need for the performance or the optimal kind of the join, and that's where if you do this reduce side join, it is going to be slow, and if you do this map side join, it is going to be the faster, because then each of the mapper is going to do the join and give you the output, so you are not waiting till the reduce mapper completes and then you start with the join. So that's where the map side join is basically preferred one, or it's more it's like better in terms of the performance, but then it has the limitation that it only can perform this scenario where you have the large data and the small data set. Okay. So when it comes to implementation of these two join, guys, so the reduce side join is simple, right? So where you have both the data set, you label the data set, and then you send it to the reducer where it basically aggregate that data set. In case of the map side join, you have to basically, what you have to do is you have to take this small data set, distribute it across across all of the mappers, and then perform the join, right? So I will show you with the code like how you do this stuff. So to enable this, what you have is you have a mechanism called distributed cache. So whenever you are implementing this map side join, you are using this distributed cache to add your file or the small file to the distributed cache. And what you have in the Mapreduce framework is it will maintain a directory where you can add these files. And once this file has been added there in the distributed cache, during whenever you run your program or whenever you want to do the join, you can do something called get local cache file, and it will basically get the list of the files. And from there, you pick the file which you want to read and then perform the join. When you want to add the file, you use something called distributed cache.add cache file, and you submit your file which you want to add it to the distributed cache. So that's why you will implement this distributed cache, and then you will use that while doing the join. this, let me show you the example like how to do these two joins in a Hadoop kind of framework, how to go for the Mapside join and how to go for the reduce side join. Okay, so let me get the program here. So first I will show you guys the reduce side join, so that's easier one to implement. And once you are good with that one, I will show you the Mapside join. Okay. So let me get the data set as well, so that you guys get the clarity how we are performing the join. Okay. So yeah, I'm going to guys, in case if you have any clarity, like like you need to repeat of these concepts, the distributed cache or the Mapside join. While I'm explaining that, I will talk about that again, so that way you will get the clarity. Okay, hold on. Okay, so the first thing what I'm going to do guys is I'm going to talk you about the reduce side join, how you do basically the join of the data set. If you have the two data set and both of data set is not the small kind of thing, and you want to basically perform the join operation when you are doing the or when you are running the reduce function, that particular step you want to do the join. So in that case you can go for the reduce side join. So what kind of the data we have? So let me introduce it with the two kind of the data files which we have here. So we have the data file, one is called transaction data and another one is called customer data. So in case of the transaction data, what you have is you have all this transaction ID, date, then the customer number, customer ID, then what's the amount of the transaction they did with us, then what kind of the equipment they bought and what kind of the saving, which state they are and all those stuff like Florida and all. Okay, and then what you have, the customer data set is basically a mapping of each customer and what is the customer name and what is like the age, what kind of profession. So basically to know more detail about the customer. So now what you are doing here is you are basically combining these two data set, transaction and the customer. So these two data set you are combining together and you are deriving certain logic. So let me tell you like what kind of the logic we want to derive from this join of these two data set. Okay, so let me get this batch file here. Is it our file? Yeah. Okay. So let me pick two rows and then I will tell you like how we are going to have this particular join. Okay. So what is the data set we have guys here? We have two data sets. So let me take one of these lines guys. So for this customer, I have this data set. This is one data set I have. And let me see this customer another data. Okay. So I have another data from this customer and that's this one. Okay. And then where are the details for this customer? So this is here in this particular first line. So I will take that and I will store it. Okay. So now first let me explain you the simple join guys, and then we'll talk about the program, how we do that. Okay. So now what we want in this particular join guys, we want to do very simple stuff. It's not like the first time you will be seeing any kind of the join of the two data set. Only thing is what will be new here is like how to do this join with the Mapreduce program, right? So that's the only new stuff which you will see. Then the kind of the join which we are doing, it's going to be similar like what we have with normal join for the two data set. Okay. Okay. So now what we want to do in this join is guys, we have two data set. This is the customer ID, which is coming in each transaction. So this is the transaction data we have, and this is customer data we have. Okay. So now what we want here is first understand guys this particular problem. Okay, and then yeah. Now, what we want to do is we want to join these two data sets. So for this, like, what is the common thing? This is the customer ID. That's going to be the common stuff, right? Now, what kind of the join we want is for each customer, the objective of the join is to basically get the number of the transaction for each customer. Okay, so that's like one thing. And the second stuff what you want is the amount, total amount what they have transacted. Okay, and then the third stuff what you want to get is along with the customer name you want details like customer name instead of transaction instead of customer ID. Okay, so basically more details along with the customer ID. So that's all kind of the join which you want to perform here. Okay. Okay. So now what you have to do is, if you have to do this join, guys, with these two data set, forget that there is any kind of the SQL interface. So the people who are from the SQL background, for just like for a moment you forget it and just think of like if you have in a program how you will implement that. Okay. So what you have to do is from the program you are going to read this particular data set, guys. Maybe in an array kind of thing you will read that, and that will going to be the comma separated value. And then from here you are going to pick these two data sets, right? So basically you will be interested in the customer ID and the kind of the transaction amount which they have done, right? So that's all will be your interest. And from this customer file you will be interested in these two details, customer ID and the customer name, right? So now what you do is you pick these two data set. How you will pick? Simple array, you put in array and you just take these two index, you will get the data. Now what you have to do in case of processing this data set or get this number of the transaction is whenever you have this particular data set, the data which is coming from the transaction, whenever you see a input data set, you have to just keep incrementing a value. So maybe you can have a counter, and that should always just keep incrementing whenever you have the value, right? So it will give you how many number of entry you have, those many number of the transaction they have done with us. Simple. If you want to get the total amount that they transacted with us, so whenever you are iterating through, you have something called the amount, and in that you keep adding the value which you get for a particular customer, right? So that also you keep adding, and you will have this value is stored there, right? Now, only thing is, once you are done with this one, so instead of 4001, whatever the customer ID, you look into this data set and you get the customer name. So that's what you have, the customer name you pick from here. And then once you have this one, you output all these things together. And that's what is going to be the expected output from the join. Okay, so that's all we want to do from this particular join. Okay, now when I tell you these two things, guys, right? So what you can do, you can have two mappers. One is basically going to do these two mapping from all the input data set. It is going to pick these two column and can give you. Then you can have another mapper that basically going to process these two data set, right? So you can have two mappers which is going to do that. Now, only challenge you will have is like if you get this particular key. So both of the the processing, the key is going to be the same, guys. So this is going to be 4001 and 4001, right? So that's the customer ID, that's going to be the key. Now you need to differentiate like when to pick the customer name, and for that what will be the input data set, and when to pick the transaction amount. So for that what you have in the reducer is like whenever you are reading the transaction data, you will always label this data as the transaction. So you will mark the data as that this is the data which I read from the transaction, because both of them are going to be using the same key. So we'll mark a transaction. Whenever you will read the data from the customer, you will mark that, label that data as customer. Once you label that, you send it to the reducer. It is basically going to iterate through all the data set which we have for the same key. So all this data is going to be combined and come to the same reducer. And there, while reducing, it will use this transaction to basically calculate the counter and the amount. And once that is done, it will use this customer to get the customer name, and then it will be done. Okay. So with this, let me show you in the code like how it looks like. Okay. So here once again guys, we take the input data set and we set the mapper class, reducer class, so all those things remain same. Only thing is if you have to run multiple mappers as part of your Mapreduce program, so that's what you do, multiple input path, and you specify the argument 0 that goes to the mapper class, then you specify argument 1 that goes to the transaction mapper class, and then you have this as the output path. Okay, so that's way you can run the multiple mapper. You have to specify multiple input format, basically, kind of thing. Okay. Now, once you have done with this, what you have is, if you see here the customer mapper class, what it does is, it reads the data which you pass, basically the customer data set, and it segregates the data based on the comma, the split, right? And then it stores the data in a variable called parts. Okay, array called parts. That's basically a string array, and from this array it picks these two data set, part 0 and part 1. So what the part 0 and part 1 guys? So this is basically part 0 is the customer ID and the customer name. So these are the two things it picks from here, and it labels this data set as the customer data set. When it's come through the transaction mapper class, what it does is it again split the input data set into an array called part. So what it means is it will split all these input records into an array. And once the data is split in array, it will pick basically the part 2. So what part 2 means? This is 0, this is 1. So this is going to be the part 2, that's the value it's going to pick. And it's going to pick the next value, that's the amount. So it's going to pick part 2 and the part 3, and it's going to label this data set as the transaction data set. Now once that is done, basically the same key data, it has to go to the same reducer so it can do basically the aggregation. So for that, what you have is, you have these two data sets coming together to the reducer. So that's what you have implemented in the reducer. And what the reducer does is it basically iterates through all the values for a given key till you have the list of the values. And for that, what it does is it see that if this particular stuff is equal to a transaction, it will keep incrementing this counter value, and it will keep adding that amount to the transaction. Okay. And once that is done, once this all the transaction record has been processed, it will look, the next value will be the customer. So if it is equal to the customer, it will get the part 1, and that's what it's going to output here as the count total along with the name, and that's what you will have the output here. So that's what it's going to output from the reducer. Okay. So that's the the simple logic you have to implement it for doing the join here using the reduce side join. So now quickly let me show you the demo here, guys. Okay, so this is something which you are using. So I will use the same program here, guys, the same project here, guys. Okay, so before that I have to get the data set for you. Okay, map join. Okay, so this is the file we have. So same logic. So all of these programs, guys, whatever I am discussing here, everything is available as part of your LMS access. So all these programs you can get as part of the LMS access, and you can execute that. Okay. So now all I have to do is, guys, I have to provide this input data set and the output data set. So I will go here and this customer and the transaction data set I have. So let me quickly get that. Copy and go here. And here. Okay, so what I will do is cd Okay, so we have these two data set here, guys. One is the customer, one is the transaction. So to process that in Hadoop, what we have to do is we have to add this. I will show you Vikas one program with the sys out. Okay, I will show you. Show you. Give me some time. Okay. So what you have to do is you have to move these two data set inside HDFS. So first, let's do that stuff, guys. Control L. Okay, so where we keep our data in this one? Okay, Hadoop fs hyphen mkdir, and then instead of partitioner, we are going to do is reduce side join. Reduce side join. Okay, and then move it Hadoop fs hyphen put, and then take this customer data and move it into this. And then let's come back here, and instead of this customer data, let's take transaction data set and move it here. So now once you have this data set available here, guys, Hadoop fs hyphen ls and this reduce side join. So what you can do is you can give these two data set input to the, okay, so before that we have to create the jar file, guys. Okay, so you do stuff. Okay, so you do export. Okay, jar file next, and instead of custom partitioner, we'll do reduce side join. Next. Okay, finish. Okay, so do we have the jar file getting created? No, this is stop. Okay, so this is the jar file which got created here. So Control L, ls minus lrt. So you have the reduce side join. So let's run that quickly. Hadoop jar, and this is the jar file name, and take this input data set. So okay, so go back to the program and let's see what the first mapper we are running. I think argument 0 is customer mapper. Okay, so customer data set will give that. So the first we will give is cust data set here. Okay, and then you give transaction, and then finally you give the location where it is the data, where you want to store the output. So instead of join, output. Awesome. Okay, so the job completed now. Now if you go back here, and if you refresh, so you will go to advanced Mapreduce, and then you have the reduce side output. You see here the customer ID has been replaced by the name, how many times the transaction was done, and what is the total amount of the transaction. So that's where it's able to join the data set. Only thing here, guys, this join is much more involved than what you would have thought in terms of doing a simple join, right? So that's what the only thing, but it's able to do the join, and you can see that it will distribute the data and do the join in parallel, right? So across multiple reducers. So that's why it's going to be faster. Only thing is it's a bit more involved in terms of doing the join. So with this, let me get this Mapside code, and then you say like how to do the join. So what you have in this Mapside join, guys, is like so when you go for the Mapside join, when one of your data set is small, what you do is you do something called the Mapside join, and in that Mapside join, the smaller data set whatever you have, you distribute across all the nodes in the cluster, so that that particular data set can be referred while you are processing the data in Mapper. And the reason why you need to distribute the other data set across all of the mappers, because each of these mappers, right, whatever you have inside Mapreduce program, they basically run independently, so they don't communicate with each other. So whenever they are doing the processing of your input data set, you need for each mapper the visibility of this the other data set available in total, so that they can do the matching records and joining on that data set. So what I'm going to show you here is, guys, is like one example with the Mapside join where you will have the two data set, and one of the data set will be distributed across all the mappers, and then you will perform the join. Right. So here you will see this distributed cache and adding that file to the all the hash table. Okay. So okay. So before that, let me show you the data set as well. We have two data set here. Okay. Okay, so what we have in terms of the data set here, guys, is the data set like this. So you have two data set. One is in abc.dat and another one is in the DC input. So what you do with these two data sets is you basically have one data set like which is these are the states which you have in India. So like these are the short form of the state name. So this is like UP, MA, BI, and WB. So the complete name of this state, it is available in this file called abc.dat. So that's going to be this file where you will do basically the lookup of the data, and from that lookup you will get the complete name of the state, and then you want to replace in the output. Okay. So now what you do is whenever you are doing the join of these two data set, what you can do is this particular file, right, which is having the basically the mapping of the state name and the the complete name of the state. So that particular stuff you can basically distribute across all the machines, so that whenever you are processing these input records, if you want to get a matching state for this particular column, you can look to this data set, and then you can fetch the second column, and in that way you will get that output. So for this, whenever you are implementing a distributed cache, all you have to do is you have to add that particular cache file with the help of add distributed cache, so that it will be available to all the mapper. And then when you want to get that data set, you will use something called get local cache file, and then based on the file name which you provide, it will get that input data set, and then you can join that together. So if you come back in the program and you see here, guys, so what you have here is you have the two data set, one data set which you want to distribute across all the machines. So that's basically abc.dat. So this is the this particular file which you want to distribute across all the machines. So how you distribute that? Whenever you are starting your Mapreduce program, you have something called distributed cache, and then you use add cache file, and you pass the path of the URL where this particular file is. So you can give this URL either in the HDFS guide or in the local file system. Here in this particular program, we have provided this in the HDFS file. Okay, and then all arguments 0 and 1, those things remain same. Now what you have is when you run this particular program, and you try to basically do the join of these two data set. So at this particular point, what you do is you again come distributed cache here, and you tell that get local cache file. So it will have a lot of the cache file that will be available in the distributed cache. So what you do is, so first you do add the data file to the distributed cache. So that will be add cache file, and that's where you add the data. And then when you are running the map program, that point you do something called get local cache file, and you get all the files which is available in the hash. And from there you pick this abc.dat file which we are basically interested for this particular program. And then you do the rest of the processing, basically picking different column token 0 and 1, and then getting the state name. Right. So while doing this stuff, guys, what you have to do is you have to first identify which data set you want to distribute, and this data set should be small enough to fit in memory, because this distributed cache will be loaded into the main memory. So in case if your data set is going to big, it will not fit in the memory. In that case, your program may fail. So that's why something you have to be aware of when you're implementing this. And since you are doing the map side join, so you want to set the number of the reduced task here as 0. So that's again one thing I want to specify. So if you are doing just map side join, you don't need any aggregation. So you can set that as also the number of reduced as 0. So that's why something for if you just want to run the map programming. Okay. And based on this, you just run this program. It will be basically able to combine the data set based on the matching value which you will get for the short name of the state into this file abc.date, and then it will replace that name along with whatever you have the short name and the like this other number which is basically the population or something. Okay. So now let's go ahead, guys, and run this particular stuff. Okay, so let me close this. So go with the distributed cache and take this file. Okay. Okay. So all I was telling is like about the about like the distributed cache, about the size of the distributed cache. Okay. Okay. So now what we have to do is we have to run this program. So we need this abc.dat to be distributed inside HDFS. So let me see if this file is there. So Control L, and if you do Hadoop fs-ls. Okay, so we have this particular file available in HDFS. So that's what we are going to distribute. So Hadoop fs-cat. Okay, so this file is available here. So now what we are going to do is we are going to add this particular file to the distributed cache, and then based on that, it will be available to each mapper while we are doing the processing. So let's come back here and let's create a jar file out of it. Export. So instead of reduce side join, we'll do it Mapside join.jar. Next. Okay. So okay. So now if you want to run this particular stuff, so what you have to do is you have to okay, so other data set we have to move inside HDFS. So let's go ahead and create the data set. So go to distributed cache. Okay. So here we'll create a folder here, Hadoop fs-mkdir. And the reason why I always do a clean kind of stuff, guys, because so many times many times what happens, like if you are doing a demo and your data set get mixed, right, you get some kind of a strange kind of output, right? So to avoid that kind of stuff, I always create a separate directory. So advanced Mapreduce, and then you have distributed cache. Okay. And inside that we are going to put this file Hadoop fs-put. This is the input file we have. Okay, so now we have this one. This is the location where you have the file, so we can go ahead and run this particular program. So what you do here, Hadoop jar, and then do your Mapside join jar, and then you give the input data set, and then you specify the output data set, okay, underscore output. Okay, so now if you come back here, Hadoop fs-ls. So you see here, guys, since we run only mapper, it shows that part M00. So that's because we only run the mapper. We didn't run any kind of reducer here. So because I think you had some question with the number of reducer, so you can see here. And now you see here, instead of having the name, it also got the the complete name for that particular state along with the other content of these two files. You implement this, you add something called the distributed cache, right? So distributed cache file, and you specify abc.dat. That's where it got the one of the file. And then inside the program, when it started running, it got this distributed cache get local cache file. And there, if the file name is equal to abc.dat, it is basically splitting into different tokens and reading the data in this particular map. Okay. So this is the map where it is reading the data, and that's basically the key value pair kind of thing. Okay. Okay. So with this, guys, I think we are good to move ahead with the other concept, guys. Yeah. So the next example, what we are going to see, guys, here is the counter example. So now let's see an example of about the counters, guys. So let me first tell you like what the counters is. So counters are basically, guys, a mechanism where if you want to get some kind of the operational detail when your job is getting processed, and if you want to see some kind of metrics around that. So in that case, what you can do is you can use counters, and that will basically help you to get some kind of computational detail if you want, right? So you can define a different kind of the counters, and it will basically keep incrementing that value based on certain events which you specified. Like if you want to count how many null values are coming, or how many values are coming for a particular month or day or from a company. So if those kind of the counters which you want to get from all of the data set which you are processing, you can implement counters. And what Hadoop does is basically Hadoop, whenever you specify the counter, it will automatically sum the the counters from all the different tasks which runs in the Mapreduce, and then you can basically get all these counters for a particular event, like whatever event you specify. Based on that event, it will keep incrementing the counter value, and once that's done, it will sum the value by the Hadoop framework and will give you the output. Okay, so that's the logic we have for counter. So it helps many times, like implementing a counter is because if you want to see like how many whenever you process the data, you will have the the correct data which comes to the output, but there are certain scenario where you want to look like if any data is getting discarded by your Mapreduce framework, what is the number associated with that? Right. So suppose if like a lot of null files are a data set which is coming with the null in a particular field, and if you want to count that, you can use these counters which will basically aggregate the data from all the mappers and then give you the output. So the example data set which we have here and which we are going to basically discuss here is, let me show you the data set. So the data set what we have here, guys, as you can see on my screen, right? So we have a very the data set where we have one of the column that's basically the text column, and the other column is some number. So these numbers are nothing but a Unix timestamp case. So what it does is in this particular value, like suppose whenever you are processing this input data set for any kind of the map and the reduce task, and if you want to basically know whenever you are processing these timestamp data, you want to count like how many records it's there for January, how many records are there for Feb, or how many records are there for March. So if you want to get this kind of count, and since this data is going to be distributed across all the mappers, so you cannot have a shared variable that get mapped. So Hadoop framework internally provides you this counter mechanism. So by using that, you can get this the value aggregated, and that's where in this counter is going to come as an help to get this operational detail. So the examples of all this is going to be like, suppose if you are processing a huge data set and if you want to see that whenever you are processing the data, what time a particular load is coming from the server, what is the maximum data you are getting based on like particular day or particular hour, and you want to, based on that, you want to place your Hadoop cluster. So all those kind of stuff, this counters is going to be a very good indicator for you in terms of understanding your data, understanding the operational aspect of your data. So now, in our case, since this data is, guys, is going to be the Unix timestamp data, so we are going to get like how many of these input records are for a particular month, like for January, how many records are for Feb, and how many records are for December. So that's what the kind of the data set which we want to get it from here. So for that, what we have done here is in this particular program, guys, it is having a enumerator. So that's the month is the enumerator we have, and inside the value like December, Jan, and the Feb. And then what you do is you basically implement the mapper function, which takes this input data set, and all we want is like whenever the different mapper is processing that input data set, they should keep counting like how many records we have for each particular month, right? We don't want to do any aggregation here, any summarization of the data, and that's what you said, that job set the number of the reduced task is 0. Once that done, rest all the things like setting the mapper class, reducer class, providing the input output path, so those things remain as it is, right? And now it comes to how to add sysout statement. So you can see here, if you add these statements, these value will get printed on the command line, as well as if you want, you can see that in the job tracker. Okay. Okay, so now what you do that is you keep looping through all the input data set you have, and wherever you get this month is equal to a particular month, like this is simple, the timestamp data you have, and from the timestamp you do get month, and based on the month you will get basically the integer number. So if it is 11, it is going to be basically December. So you keep incrementing this counter, so it provides you this increment method, and by using this increment you can keep increasing this enumerator value. Now here one more optional thing is, guys, this increment, it can happen based on whatever the way you want to increment the data. So like if it is December data, you want to increment it by 10. If it is January data, you can increment like each input January record, it will add the value of 20. So if you have 2 January, it will be 40. If you have 2 December, it may be 20. Right, so that's why it is configurable kind of thing. So similar way, if it is Feb, you can increment it by 30. So that's why basically like for each Feb record, it will basically 30, 60 kind of thing. It will be there. Okay, and whenever that's there, you basically output that data set to the console. So with this, let me basically run this program and show you how to see the counters in action. Okay. Okay. Okay, so this is the program which we have, guys, here for the counters. Okay, so what we are going to do here is we are going to run this particular program, and then we'll see that in the output how this sysout gets printed, right? So that's one of the things which we'll see here, this output, and along with that, what we'll see that all these the metrics what we are putting here for each month, December, Jan, and Feb. These value will also come as the regular whatever the output we get from the job tracker. So there how you have like how many mappers input got processed, how many reducer output got processed. So similar way you will have all these counters also getting printed there. So let me show you how to so first let me create the jar file, guys, here. So do export. So you have counters.jar. Next. You have basically this counters.jar. That's what you created. Now let me get the input data set here, guys. So so you go to here, this directory cd. Okay, so this is the input data set we have. So if I do cat of this data set, you will see that there will be more records like what we have in the the text file in the Windows. So based on this, how the data is going to come, we are going to see. Okay, so let me add it. Once that there, we'll move this data file there. Hadoop -put. Okay. Now what we are going to do is we are going to run this particular program. So basically this counter.jar. And at this time we will not see the output, guys, but we will basically focus whatever the stuff it's coming on the command line. So you are going to do Hadoop jar and the jar file name, so our case counters.jar, and then input data set. Okay, so that's what the kind of stuff we are going to run here. Now you look on the screen, guys, how the data is coming here. So if you see here, you can see the two custom counter which we implemented. So based on that, if the value is there, this data is coming here like December, and January the data set is coming. So you can see if you add the sys print out statement, you can see those data is getting printed also here on the console. In Feb we didn't have any data, so that's what you see it at 0. For January I think we had I think 4 records, and for December there was 1 record, so that's what we see. January was incremented by 20, so I think we had 6 records that were for the January and 1 of the record that was there for the December.